All right, so let's try to prove this real quick. For you guys, anybody remember this, like what the answer is for the block? All right, so let's just solve it out. The initial energy has to equal the final energy. What 2 points are we? Where are we starting? Where are we ending? Okay, good. So that's the first substitution. We have to put the height where we're looking at is going to be at the top of the loop, and that height is going to be 2r. Okay. We also know that the minimum velocity is what. Since we're at the top, we need that minimum velocity. We can see mass cancels, so we have g big H equals 1/2 the square root of gr squared. Right, and this is going to be 4/2, so that g cancels, and the minimum height needed is going to be 5/2 times the radius. Okay. Substitutions are this for height, this for the minimum speed, because that's where we're at. We're trying to find the minimum height. All right, so we have to have, whatever the radius is, the starting height has to be 5/2 times that. So now we have to look at when this object is rolling. Just going to get rid of that. You can always go back and look at that. All right. Now, same situation. This is, we're just saying this is little h. Still r. Still looking at the top. Okay. So, if we release this from rest, and then the ball is going to rotate and roll through that loop, what is our starting energy? Okay, it's still mgh. When it is at the top of that loop, what are the energies that exist? So there's still mg2r. And there, which type? Is it rotating? Yes. And we have the equation for rotation there. Is it moving translationally? Okay. Bless you. Now, when it is rolling smoothly, this is the I around its center of mass, and this is the velocity of the center of mass. That's an m. We do need to know that the I of a sphere is 2/5 mr squared. Of course you can't. 2/5 is for a, this is for a solid sphere. Solid sphere. Okay. So let's just go through with the necessary substitutions. So we're going to get this in terms of just r, just like how the last proof showed 5/2 times r. We're going to have something times r. So we have to get rid of what? We have to get rid of the m's. We have to get rid of the I. We have to get rid of the v. We have to get rid of the omega. Okay, we have to get rid of it and the g. So all that stuff has to go away. So let's make our first substitution. 1/2 times 2/5 mr squared, and I have to do something slightly different here. This is big R, so this has to be little r, because it's the radius of the sphere and not the radius of the loop. So let's differentiate that. And then that is omega squared. And the next substitution is square root of GER. That is the radius of the sphere. And we still have our potential there. What cancels now? M's. Okay. We have to get rid of the omega. Now we have to say this is moving, rolling smoothly. And that means there's a connection between the angular velocity and the linear velocity. Yeah, I'm going to do that because I already started writing. So we have to get rid of omega. What is the relationship between omega and the translational velocity?
It's velocity
Okay, so that is going to be replaced with v over r, so it's, and both are going to be squared. So we're going to have v squared over r squared, and continue with m's are gone. Okay, so that's the next substitution. You can see that the radius of the sphere cancels out, and this is going to be the velocity of the center of mass, because this is the angular speed with respect to the center of mass. So one more substitution. That's the velocity of the center of mass, which has to be square root of GER. I'm sorry, the r's cancel. Bless you. G, gone. What did I forget? I didn't write. What did I write here? Big R. Okay. So everybody okay? See what I missed?
Yeah.
All right. So now we have to add those all up. Can somebody math? You're getting 2.7 R?
27 times.
We okay with that? Is there any checking of that math?
It's right.
So 2 is 7 plus 20.
Little h has to be greater than big H.